Stop scrolling. If you are preparing for GCSE Chemistry examination, this topic appears almost every year, and most students lose marks on chromatography calculations and practical questions. In the next few minutes, I will show you how chromatography works and the exact required practical steps. I will show you how to calculate the RF value fast, the common mistake examiner loves asking, and the hidden exam trick that separates grade 5 from grade 9 students. Trust me, by the end of this video lesson, you will answer chromatography questions with confidence. Let's go. Paper chromatography is used to separate substances in a mixture such as food coloring, ink, or dye. Now, can we identify the components that make up our setup in figure 1? We have the lid, beaker, start line. We have the solvents, we have the dye spots, and right here we have the chromatographic paper. In the chromatographic practical, when the investigation finishes, the pattern of spots produced is called a chromatogram. Now, here is a very important exam point to note. One spot indicates a pure substance, while more than one spot indicates a mixture. Examiners ask this a lot. Note that in paper chromatography, the paper is the stationary phase, while the solvent is the mobile phase. The mobile phase is either liquid or gas, while the stationary phase is a solid or sometimes a thick liquid. During the chromatographic investigation, the solvent moves up the paper, carrying dissolved substances. Substances that are more soluble in the solvent travel further, while substances strongly attracted to the paper move slowly. Here is the exact method you should know when investigating paper chromatography for GCSE exams. You are expected to draw a pencil line near the bottom of the paper and place a small spot of dye on the line. Next, you are to put solvent in a beaker and suspend the chromatographic paper in the solvent. Ensure that you keep the solvent below the start line and cover the beaker with a lid to stop the solvent from evaporating. Next is to allow the solvent to rise up the paper, but you are to remove the chromatographic paper before the solvent reaches the top. Then you are to mark the solvent front immediately, just like we have right here. The solvent front, solvents front. So you mark the solvent front immediately. So after marking the solvent front, you leave the paper to dry. Now listen carefully, because this is a classic exam question. Why do we use pencil instead of ink to draw the start line? The answer is very simple. This is because ink dissolves in the solvent and affect the expected results. Also note that if the solvent reaches the top of the chromatographic paper, it implies that you left the investigation too long. Another common question is this: why will a dye remain on the start line? Note that a dye will remain on a start line if it is insoluble in the solvent used or strongly attracted to the paper. Now, how do we determine the retention factor, that is the RF value, on a paper chromatography? Now let's calculate the RF value, which is one of the easiest marks in GCSE chemistry. The retention factor formula is given as the ratio of the distance moved by the substance to the distance moved by the solvent. Can we consider this practice question? Determine the RF value for the red spot right here. It can be seen that the dye moved 2.4 centimeters. That is, 2.4 centimeters represents the distance between the start line and the center of the red spot, while the 6.0 centimeter denotes the distance between the start line and the solvent front. Now, can we calculate the RF value for the red spots? So we have RF equals, what is the distance between the start line and the center of the red spot? That's right, 2.4 centimeter over, what is the distance between the start line and the solvent front? That's right, 6.0 centimeters. So we have over 6.0 centimeters. So this will give us 0.4, okay, without units. RF value has no unit. Moving on, can we consider another example on RF value calculation? What is the RF value in figure 2? Given that blue spot moved 6.8 centimeter. That means the distance from the start line to the last blue spot right here is 6.8 centimeter. And solvent moved 7.2 centimeter. It implies that the distance between the start line and the solvent front is 7.2 centimeter. Now, can we determine the RF value? I would like you to pause the video while you answer this question. All right, can we determine the RF value together? We have retention factor equals the distance moved by substance is what? 6.8, while the distance moved by the solvent is 7.2. Therefore, by the time you press your calculator, you're going to have 0.94. No units. So the RF value for the blue spots right here is 0.94. Make sense? Note this for your exam. If two substances have the same RF value in the same solvent, they may be the same substance. A quick revision, you may be asked to complete the label in figure 1 right here. So all you are expected to do is to identify the lead, beaker, the start line, the solvent, the chromatographic paper, as well as the dye spots. In figure 2 right here, how many different dyes are in substance Y? The answer is what? That's right, the answer is 2. We have 2 dyes in substance Y. Also, which of the 4 dyes A, B, C, D could be in substance Y? That's right, it is dye A, because dye A has the same retention factor as one of the components of substance Y. Also, dye A travels the same distance as one of the components of substance Y. Moving on, how do the results in figure 3 show that the spotted dye is not a pure substance? Trust me, this question is very simple. This is because it can be observed that more than one spot move up the paper. We have the red spot, the blue spot, and the black spot moving up the chromatographic paper. Therefore, it is not a pure substance since we have 3 spots moving up the chromatographic paper. So which spot had the greatest RF value? That's right, the black spot, right? If this video lesson helped you understand paper chromatography better, then you are already ahead of thousands of GCSE students. Drop your target grade in the comments, grade 5, grade 7 or grade 9. And don't forget to subscribe to Organotope Chem Clinic for more GCSE chemistry revision, exam tricks, required practical and calculation tutorials. Your grade 9 journey starts now.